Hello again. Welcome to our first proper training session, Introduction to SEM. In this session, I will define the technique, highlight its key advantages, explain briefly how the technique works, and show an example that illustrates how the technique may be used to test management theory. Structural equation modeling is one of the multivariate techniques in statistics. It is a multivariate technique because it handles multiple numerical data, that is, large sets of variables. Before we look at the principles of SEM in more details, let me just say that SEM is one of the most frequently used techniques in quantitative studies. My quick search of the EBSCO database shows that since 2000, about 5,381 studies published in academic journals refer to the technique. According to Babin, about half of all submissions in marketing nowadays use structural equation modeling, and the principal reason for its popularity is its ability to breach the theory development, measurement, and hypothesis testing. I'll show you later in the lecture how this is done. For now, it will suffice to say that SEM is very suited for dealing with theories in management. Why is that, you may ask? Management is a social science, and similar to other social sciences, the objects of its inquiry are abstract and not easily observable. Consider for a moment a hard science, such as chemistry, physics, biology, or medicine. Their objects of research tend to be tangible and easily seen. For example, chemists might look at chemical substances and their properties. Medicine would be interested in bodies and their parts. By contrast, management deals with abstract phenomena, concepts that cannot be easily identified or directly observed. Satisfaction, performance, motivation, risk, trust, loyalty, or engagement are all such abstract, unobservable concepts. How do we research those? In quantitative research, we tend to develop measures, that is, define the concept and find a set of variables that reflect it. Quantitative surveys would typically include a set of questions that measure a concept. Let's have a look at one such concept, job satisfaction. Here is a set of 4 questions which capture different aspects of being satisfied with one's job. These are based on Sochley et al. Study of salespeople. Such sets of questions or statements are called scales. Each question or statement within a scale provides a measure. For example, respondents are asked to disagree or agree using a rating scale between 1 and 7, and their answers are recorded for further analysis. The individual's ratings of a statement, for example, their assessment of whether the work gives them a sense of accomplishment, would represent a variable, that is, a set of numbers that correspond to the ratings by each of the respondents. In survey research, variables are frequently referred to as items, like in questionnaire item. To sum up, the abstract management concepts appear in survey research typically in a form of sets of questions or items that attempt to measure the differences between the individuals. In mathematical terms, testing management theory involves looking at statistical relationships between the answers to different questions. Second challenge within management theory concerns its messiness. Management frequently deals with interrelated concepts where multiple factors need to be taken into consideration at the same time. Let me show you an example of such theory. Bagozzi's study of salesperson performance, published in Journal of Marketing in 1980. Bagozzi argued that salesperson performance depends on their verbal intelligence, i.e., how well they can put forth an argument, and self-esteem, that is, how confident do they feel about their ability to carry out the job. He also suggested that person's motivation plays a role because it influences satisfaction, which in turn affects performance. In fact, He argued that there is a recursive relationship between satisfaction and performance. The more satisfied you are, the better you perform, and vice versa. The resulting model depicts a complex set of relationships where the focal performance or satisfaction result from a number of other influences. A key advantage of structural equation modeling lies in its ability to handle the messiness of management theory. Specifically, SEM is very suited for dealing with large datasets with multiple items where variables are related to one another, as in measurement scales, and where the relationships between sets of variables are not straightforward, that is, they involve mediation, moderation, or recursiveness. Multiple dependence relationships are one aspect of messiness, and the case of performance in Bagotti's model is one good example. As you recall, performance is influenced by satisfaction, which in turn is impacted by motivation. Mathematically speaking, the dependent concept performance is affected by another dependent concept, satisfaction, which is then influenced by yet another concept, motivation. The ability to handle such multiple relationships is a major advantage of SEM over regression, which can only deal with one dependent variable at the time. For example, to estimate the three-way relationship between motivation, satisfaction, and performance, you would have to calculate the relationship between satisfaction and motivation first, and only then go to the second equation between performance and satisfaction. In terms of its statistical properties, SEM combines factor analysis and multiple regression. Similar to factor analysis, individual concepts within the model are measured with multiple items or variables. Our example concept of job satisfaction is captured by ratings concerning 4 different statements. This principle applies to all concepts within SEM. For example, Bagotti's model included self-esteem and verbal intelligence, all of which were measured by sets of variables or items. SEM is similar to regression because its fundamental purpose is to test relationships between concepts, that is, to verify whether motivation affects satisfaction, or if satisfaction is positively or negatively related with performance. When the properties of factor analysis and regression analysis come together, we get a complete structural equation model. It is worth mentioning that another key advantage of SEM over regression lies in its treatment of measurement error. I do not want to go into technical details here, but it's important for you to know that any relationship between two concepts measured on scales with multiple items will be stronger in SEM than in regression. In other words, it's easier to prove the existence of a relationship in SEM, and whatever relationship you may find would typically be stronger in SEM. Let me recap. We talked about the application of SEM in management, and I have explained how the properties of SEM make it very suited to address some of the challenges of testing management theory. I have also shown you the first example of a structural model and explained how this model combines factor analysis and regression analysis. In the next tutorial, we'll consider in more detail the elements of structural models and the associated terminology and graphical convention. See you then. Bye.